All right. You are welcome to GMAT 41's Fastest Finger Academic Challenge. So we have to conclude what we started, of course, for the month of June 2025. What have you learned so far within this month? And of course, following stage 1 of yesterday, we want to conclude with stage 2 as we look at maths and physics. All right, so be looking forward to having you friends join the challenge. Let's round off with a little time we do have today. Okay, so I'll be waiting a moment to have you friends connect. I had to recreate the class. I had to recreate it. Network seemed to be disturbing today. So let's see. Once you join, hit the like button and share the link to your friends, to your department, your WhatsApp group so that others can connect. So I am waiting for a little moment to have you friends join. Once you join, give a like to this challenge that GMAT 41 has decided to launch in order to assist you friends, to help you expand the network of your brain, to test your preparedness with prize attached, Still waiting. Let's see. Network this evening is very down. The network is really, really down. The network is really down this evening somehow. Eziago Emmanuel, good evening. You're welcome to join the class. And I hope you're doing fine. Just waiting for a moment for some to join before we kick off the challenge for today. We are looking at maths and physics. Math 102, physics 102. Let us have some friends join before we kick off. The network this evening is just something else. It's just something else. All right, so I think I have some friends join now, right? We have to kick off. There is no time. We have to kick off. Please, once you join, indicate your presence. Once you join, indicate your presence by giving this a like. Give this class that has been hosted a like, and you can type in something. Get ready for question number 1. We'll be starting with Math 102. We will be starting with Math 102. Remember the instruction. The question will be dictated. Then you have a time frame within which you have to drop your answer. So let us kick off. We are some minutes into the time now. So our very first question is going to appear. Like I said earlier, already from yesterday's challenge on Chem 102, 2 persons are already tying on this race. 2 persons are already tying on this race, appearing 3 times as the fastest finger. However, I want to make it very clear that the table can still be overturned. The table can still be overturned. Yes. So for those that appeared once, being fastest finger, don't give up. You can still overturn the table. Let's go straight to our very first question. Let's go straight to our very first question, and here we go. Please, I'd like to say this, okay? I'd like to say this. Math and physics both are five questions, because I just want to have us get this done. You know, this is the first time we are just hosting this show. Are you getting right? This is the first time GMAETS 41 is hosting this show as a test to see what happens. So I just want to have us round off this first, attempt of this challenge, and then we'll see how it goes. So instead of 10 questions for maths and physics, we are working on 5 questions each. So we can do and declare the results tomorrow. Already from yesterday's on, I already told you that 2 persons tied, and I made the announcement through our community. You can actually check on that. So our very first question goes this way. Evaluate integral 2x plus 4 all over 6x squared plus 24x minus 5 dx. Evaluate integral 2x plus 4 all over 6x squared plus 24x minus 5. The options you have, the option A, 1 over 6 ln open bracket 2x plus 4, close your bracket, then plus A, where A is a constant of integration. Option B, ln open bracket 6x squared plus 24x minus 5, close your bracket, plus A. Option C, 1 over 2 open bracket 2x plus 4 all raised to power 2 plus A. Option D, 1 over 6 ln open bracket 6x squared plus 24x minus 5, close your bracket, plus A. So what is your answer? The time given to this is 15 seconds. 15 seconds. And your time starts now. 15 seconds. Remember, write the question number. This is question number 5. Question number 4, you indicate your answer. I'm still giving you the opportunity for your 15 seconds to begin to count. We are 10 seconds gone. Time up. So let's have your answers as you have. So drama moment. You suggested option D. That's question number 5. Option D. Eziagu Emmanuel. Option D. And that, of course, is the correct answer. 1 over 6 ln open bracket 6x squared plus 24x minus 5, close your bracket, plus A. That is the correct answer. Ezebika Chima, you also dropped that. The correct option is option D. The first entry that was correct here is by drama moment. So I am indicating that drama moment. If you have been following up with GMAT 41's classes, you agree with me that this particular question shouldn't even take you 10 seconds. It shouldn't take you 10 seconds to answer. So if you have not been following with our classes, make sure you stay tuned. Whenever there is a content on the channel, follow through and see what you have there. And these are classical exam-related questions. Okay? All right. So the correct answer to this question is option D. This is question number 5 in Math 102. Question number 5. So take a look at it. We are moving on to the second question. Meanwhile, the simple analysis to this question is, if you differentiate the denominator, you will get 12x plus 24. That 12x plus 24, if you factorize 6, you will get 6, open brackets, 2x plus 4. And that is exactly what you have in the numerator. And for such integral, the solution is simply 1 over that denominator constant difference, which was the 6 you factorized, then ln of the given denominator in the question. All right, let us move on to question number 4. Indicate question 4 and get ready for the question. Indicate question 4 and get ready for the question. So here we go. Find the area enclosed. Find the area enclosed by y equal to 8x, open bracket, x raised to power 2 minus 5, close the bracket, raised to power 3. The x-axis and the ordinate x equal to 0 and x equal to 1. You have the options provided there, as you can see. Option A, 881 square units. Option B, 660 square units. Option C, 256 square units. Option D, 324 square units. Option E, nota, that is none of the above. You have to find the area enclosed by y equal to 8x, open bracket, x squared minus 5, all raised to power 3. You know that x squared minus 5 is in bracket as you have there. Then the bracket is raised to power 3. The x-axis and the ordinate, x equal to 0 and x equal to 1. So 30 seconds is going for this question. It's not as if there is anything in the question, but I'm going to give you 30 seconds for it. Your time starts now. Remember, 30 seconds. We are 10 seconds gone. If you have been following up with GMAT 41's classes, this question shouldn't waste you any time at all. We are 25 seconds gone. Time up. So let us see the first correct entry. Question number 4, you have it there. The first correct entry. Grammar moments, option D. That's what you presented. Thank you for your answer. Let us see other entries. Ezebika Chidima, option A. Thank you. Let's see if there are further entries. Let's see if there are further entries. Let's see if there are further entries. Eziagu Emmanuel, option C. Ezebika Chidima, you already gave an option, and your first option is what we are going for, which is option A. I cannot take option D again. Okay. All right. I think the time is sufficient. The time is sufficient. So what is the correct answer to this question? The correct answer is option C. And the first correct entry is that provided by Eziagu Emmanuel. So I am indicating that Eziagu Emmanuel. The correct option is option C. The integral of this term, this question given to you is like application of integration in determining the area under a curve. If you integrate this term that you have here, Use substitution will solve this question. Product use substitution. And if you look at what you have in brackets, if you differentiate that term, x squared minus 5, it is going to produce the x term that is multiplying that bracket. I had released a concept, a principle, which I termed the Omaka's product use substitution principle that is used in solving questions like this. This problem is as simple as keep the 8x constant, integrate that bracket. That bracket is x squared minus 5 all raised to power 3. If you integrate it, you are going to get x squared minus 5 all raised to power 4 divided by the new power 4. And then you differentiate that bracket, x squared minus 5. If you differentiate it, you get 2x. That 2x will still go to the denominator, which means that in the denominator, you have 4 and you have 2x. If you multiply 4 by 2x, you get 8x, which will cancel the 8x that is multiplying that function. So the integral of this term is simply x squared minus 5 all raised to power 2. Then what do you do from there? Apply the limit given to you there. The limit is 0 and 1. Lower limit is 0, upper limit is 1. If you apply that limit to the solution, x squared minus 5 all raised to power 4, and you simplify that, you are going to get 256 square units. So that is the correct option, option C. And the first correct entry is that provided by Eziagu Emmanuel. Like I said, if you meet this question in exam, you don't waste your time on it. Follow up with the GMAT 41's classes, our uploads on this channel. And most of all these will be 1+1 to you. Meanwhile, thank you all for providing your suggested answer. Let us move on to the next question. Question number 3. Indicate your question number. Indicate your question number. And then let us see what we have in question number 3. Here we go. Question number 3. Identify the circle with its center coordinate. The network is really disturbing, but let's be patient and see what happens. Let's be patient and see what happens. We are on question number 3 of your Math 102, the GMAT 41's Fastest Finger Academic Challenge. The network is really down this evening. It's quite bad. Yes, keep your entries coming. Question number 3, you can see it there on the screen. But it's really blurred from this end. I don't know, it's blurred. It's not quite clear. All right. I hope we are back now. You can notice that we've connected back. So question number 3 is still open. Question 3 is still open for your answer. That's a question there. We have 2 entries now. Drama moment, you can't see anything in the screen. Can you see it now? Can you see it now? It's really network issues. So because we know where we find ourselves. Yeah, it's clear. It's clear now. It's clear now. So you can still provide your answer to this question number 3. I'm still giving the room. We have 2 entries already. All right, drama moment. Thank you. I've already posted my answer. Yes, I saw it. All right. So the correct option here is option E. And drama moment provided that answer first. That is the correct answer to this question. That's the correct answer to this question. Okay? Question number 3. The circle equation we have out of these options, right? Option B is a circle, no argument. Option C is a circle. Option D is a circle. Option E is also a circle. But where you have the problem now is with the center coordinate and the radius. If you take your time to solve, the center coordinate of option E is the correct answer. And one can quickly get the answer of this by using the knowledge of completing the square method to standardize the equation of the circle you have there. Okay? That's option E there, the circle equation you have there. If you work out the radius is going to be 7, and the coordinate of the center is -3, 4. And so the correct option is option E. Option E. Let us move on to our next question. This time, question number 2. Indicate your question number. Question number 2 of Math 102. Let us see what we've got there. What's happening? The network's still disturbing. The network situation tonight is something else. All right. Question number 2. Here we go. Define f of x such that x is mapped to y as f of x equal to square root, open bracket, 64 minus x raised to the power 2, close your bracket. The point of discontinuity of f of x is option A, you have it there. Option B, you have it there. Option C, you have it. D and E, you have them there. I can't read the options because reading those brackets you have there would mean that I'm still interpreting the question. It is expected that you should know the meaning of the brackets used there. So the point of continuity of this question is what? All right. So you can provide your option. I am given 15 seconds to this question. 15 seconds. And your time starts now. I hope you've processed the question. All right. You've taken time to process the question. So 15 seconds to read. We are 10 seconds gone. Remember, it's 15 seconds and time up. So what is the point of discontinuity? The options given there. Which option shows the point of discontinuity of the function given there? All right, question number 2. The first entry here is from Eziagu Emmanuel. We went for option D. The next is Arinze Umezuleke. You went for option D. Drama moment. You went for option B, B as in AB. Do you have any further entry? Do you have any further entry? All right. I think the time given is sufficient. The correct answer to this question is option B, B, B as in AB, option B. The range given there, the interval given there shows the points of discontinuity of that function given there. You know, usually most of you, per se, you may have been used to how to obtain the domain of a function. So the opposite of the domain of this function gives us the point of discontinuity. And what do we mean by the point of discontinuity? These are the values for which this function will not be defined. This function will be defined for all values from -8 to +8. This function, square root of 64 minus x squared, will be defined for all values between -8 to +8. That is to say, it will be continuous. F of x equal to square root of 64 minus x raised to the power 2 will be continuous for all values between -8 and +8. -8 and +8 inclusive. That will give you the domain, which actually goes with option A in terms of the domain, because domain tells us the point of continuity. But what I asked here is about point of discontinuity. So if the point of continuity, which is the domain, is from -8 to +8, then every other real number that is not -8 to +8, that is not within it, will now be the point of discontinuity. And this is true for all values from -infinity to -8, but -8 will not be part of it. And then it will jump from -8 to +8. It will jump all the real numbers there and start again from 8 to positive infinity. That 8 is not part of the domain. That is why in that option B, if you look at the bracket used there, you know, curved brackets. I'd explained this in one of our lecture videos that the curved bracket shows that the numbers enclosed, they are not part of that interval. So the point of discontinuity here is option B. And you can find out, pick any value from -infinity to -8. But -8 is not among, please take note. Then pick values from just after +8 to positive infinity. Fix it in that function given there, square root of 16 minus x squared. You will find out that you will get indeterminate term. Is it indeterminate? You will get infinity. That is something that does not exist. Yeah, it doesn't exist. For example, try something like a number between 8 and plus infinity, something like 9. Fix 9 for x in that function. You will get 64 minus 9 squared. 64 minus 81. Evaluate it. A calculator per se will tell you error. You can't evaluate that because it is undefined. It is undefined. So I think a better explanation again to the concept of discontinuity are the values that will make the function undefined. Like we said, option B goes with it. All right, so drama moment, you provided option B. A. Henry, you've also provided option B. That's appreciated. The first correct entry is from drama moment. And the correct answer will say that the point of discontinuity is the interval -infinity to -8 with that curved bracket, then union curved bracket positive infinity to positive 8 to positive infinity. All right, let us move on to our last question in Math 102. Our last question in Math 102, question number 1. Let's see what we've got. If f of x comma y in bracket equals if f of x comma y in bracket equals x squared plus y squared, obtain dy dx. You have the options there. Option A, minus x over y. Option B, 2x plus 2y. Option C, 2x. Option D, x over y. Option E, 2y. Following my reading the question and the fact that you have access to the question, you have just 5 seconds to solve this question. 5 seconds to answer this question. 5 seconds, that's what I'm giving. And your time starts now. We are 2 seconds gone. 3 seconds gone. Time up. Time up. Remember, the whole idea here is your ability to understand that there are questions you can solve as fast can be in exam hall. Like, you deal with them quickly, so you don't waste time. You save time from such questions and using other questions that might take your time. Okay, so this question you're seeing here, 5 seconds is sufficient for someone to get his or her result. All right. Your answers, the first entry option, the first entry has entered, the second has entered, the third has entered. Question number 1. All right, I think the time I gave is more than sufficient. Therefore, we are going to work with these options, the entries we have here. The first entry is Diago Emmanuel. You went for option B, 2x plus 2y. Drama moment, you went for option A, minus x over y. A.C. Henry, you went for option A, minus x over y. The correct option is option A. The first entry is by drama moment. A.C. Henry, you also went for option A, and that is still correct. Good. We are done with Math 102. We have just 5 questions instead of 10 questions. Like I said, Math 102, 10, Physics 102, Math 102, 5, Physics 102, 5. So we get just 10 questions in these 2 courses, right? Together with the 10 questions in Chem 102 yesterday. Good. So at the end of Math 102, because I can announce the result right away, no much stress. At the end of it, the person that came top is drama moment, appearing as the fastest finger in 4 of the questions. In 4 of the questions. So take notes. I've announced that the person that came on top is drama moment. However, the rest of you, I applaud you. Yes, I applaud you for being part of the challenge and providing your answers. That's interesting, okay? And the challenge you are experiencing now, make sure that you pick the lessons and then work on it so that you get prepared ahead of time as your exam approaches. At this time, we are now switching to Physics 102, so get ready. Physics 102, get ready. Indicate your very first question. We are starting again from question number 5 down to question 1. This is GMAETS 41's Fastest Finger Academic Challenge. What have you learned? Are you ready to win? So what have you learned over the past 1 month from this channel, from wherever you are learning from? What have you learned? So pick one of the power bites from here and get ready as we move on to Physics 102. General Physics 2. Let's see what we've got. Let's see what we've got. We are done with Math 102. Remember, you can come back much later at the end of the challenge and look through these questions. What could have been the correct answer? Or what made you select an option that is not the correct option? Could you still solve it and get the correct answer? If you have challenge, you can make use of GMAETS 41's platform. Yes, you can send your question to GMAETS 41 through this channel's community. On the home page of GMAETS 41's channel, you have the community. If you go to the home page, you see view community. Tap on that view community and you can send any question directly to GMAETS 41 on this channel. Okay? All right. I would want you guys to start making use of our community. Soon now, if you send question to me on WhatsApp and other thing, I might not respond. Make use of this community. This is a full-blown online school, like I said here on WhatsApp. I have provisions for that, but gradually we'll be making use of this channel on YouTube. Get used to it. Let's move on to question number 1 of our Physics 102. So what have we got? Question 1. Let's see. Here we go. Please, we are starting with question number 5, like I said. So indicate your question number so that once you see the option, all you now have to do is just to type. All right? Is to type your answer. So let us go straight on to our very first question. Which of the following is not correct? Which of the following is not correct about the capacitance of a capacitor? Which of the following is not correct about the capacitance of a capacitor? Option A, it increases with decrease in distance between the plates and increases with increase in potential difference. Option A, it increases with decrease in distance between the plates and increases with the increase in potential difference. Option B, it is greater in a medium of higher dielectric constant and increases with increase in charge. Option C, it is directly proportional to radius and inversely proportional to electrical potential energy. It is directly proportional to radius and inversely proportional to electrical potential energy. And then option D, it increases with increase in area of the plate and charge stored. So you have 30 seconds to provide your answer to this question. You have 30 seconds and your time starts now. We are 10 seconds gone. 20 seconds gone. Drop your answer. Time up. So let us see the first correct entry. Let us see the first correct entry. Which of the following is not correct about the capacitance of a capacitor? All right. We have our entries here. We have 3 entries already. 3 entries already. If you still wish to give your answer, you're still free to provide your answer. All right. I think the time given is sufficient for you to have processed everything necessary. So let us see the options that we have here. Drama moment. You gave the first entry and you went for option C. Eziago Emmanuel, you went for option B. Henry, you went for option D. Remember, the question is which of the following is not correct about the capacitance of a capacitor? The correct option is option A. The correct option is option A. So here there is no contender. No contender, all right? Because all entries were incorrect. The correct option is option what I said, option A. The capacitance of a capacitor, yes, increases with decrease in distance. Capacitance of a capacitor, C, is inversely proportional to distance. So in that option A, that first part of the statement is correct. It's a trap. It's a trap. Someone will go, oh, I know. Capacitance of a capacitor is inversely proportional to the distance between the plates. Oh, so it means that the capacitance increases if the distance decreases. But hey, look at the ending part of that option A. It said, and increases with the increase in potential difference. That statement is not correct. Capacitance of a capacitor is inversely proportional to potential difference. Remember the base formula of capacitance of a capacitor. C equal to Q over V. So the relationship between C and V is inverse, which means in the second part of that option A, capacitance cannot increase with increase in potential difference. Rather, capacitance will decrease if potential difference is increasing, because capacitance is still inversely proportional to potential difference. So that statement is not correct. The rest are correct. Option B is correct. For capacitance of a capacitor, it increases. It is greater if the dielectric material in the given medium is high. You know, capacitance of a capacitor is directly proportional to the dielectric. And the second part of that, option B, says that capacitance increases with increase in charge. Yes, the base formula of capacitance C is equal to charge Q over V. That relationship is direct. So capacitance increases with increase in dielectric value and increase in charge. Option C is correct. It's true of capacitor. It's a correct statement for capacitance of a capacitor. Capacitance is directly proportional to radius. Recently, there was this question I solved where we used the formula that capacitance of a capacitor is equal to 4 pi permittivity of free space times radius. Even apart from that, we know that capacitance of a capacitor is directly proportional to area, and area is directly proportional to radius, which means that capacitance of a capacitor is directly proportional to radius. If radius is increasing, capacitance will also increase. Then the ending part of option C said that capacitance is inversely proportional to the electrical potential energy. Electrical potential energy, under electrical potential, if you are defining electrical potential, which is V, voltage, electrical potential, potential difference, it is defined as the work done in bringing unit positive charge from infinity to a point in a field. So we have that formula that V is equal to W over Q. That W is our electrical potential energy. If you look at the formula I just mentioned, V equal to W over Q. V and W are directly proportional. V and W are what? Directly proportional. And remember, capacitance of a capacitor is inversely proportional to V, which means that capacitance of a capacitor will also be inversely proportional to electrical potential energy W. That is what option C said. So that statement is true for capacitance of a capacitor. Option D is also true for capacitance of a capacitor. Capacitance increases with increase in area. It also increases if it increases with increase in the charge stored as well too. So the incorrect statement about capacitance of a capacitor is that option A. And I've told you the reason. The ending part of that option A, that statement is not true. It's wrong. It's not correct about capacitance of a capacitor. I hope I've been able to give classical interpretation to this question. And of course, on this platform, we have full lecture video on the concept of capacitance of a capacitor, electrical potential energy, that explains all these concepts also. Let us move on to question number 4 of our Physics 102. Let's see what we've got. I hope you're ready. A coil has 2,500 turns. A coil has 2,500 turns. The magnetic flux generated is given as You have that symbol there, that symbol for flux, magnetic flux, equal to T raised to the power 2 plus 6T plus 7. Calculate the magnitude of the induced EMF at 2 seconds. Calculate the magnitude of the induced EMF at 2 seconds. You have the options, the option A, 25,000 volts, option B, 250 volts, option C, 4 times 10 to the power of minus 3 volts, option D, 10 volts. You have 30 seconds to solve this question. Within the time the question appeared and my reading it, and even this time I am talking, is sufficient for you to have seen the whole background about this question. And if you've been following GMAT 41's classes, just last week we treated the concept of magnetic field. Magnetic field and electromagnetic induction. So you have that. And I'm giving you 30 seconds, to solve this question. Your time starts now. We have 15 seconds gone. Time up. So let us see our first correct entry. Let's check our first correct entry. Question number 4 of your Physics 102. Let's see what we've got. All right. Grammar moment, we have option A from you. Eziago Emmanuel, we have option B. Ese Henry, we have option B. Thank you for your entries. The correct answer is option A, 25,000. And that goes with drama moment. Drama moment provided the first correct entry. How do you solve this problem? It's a very simple question, making use of Faraday's second law of electromagnetic induction, all right, that deals with the magnitude of the induced EMF. And we have the formula that the induced EMF, the magnitude, is equal to the number of turns, then multiplied by the derivative of flux with respect to time. That is number of turns times the rate of change of the magnetic flux. The rate of change of the magnetic flux is obtained based on this question given to us by differentiating that flux given with respect to time and substituting that to seconds. If you differentiate 2t raised to the power 2, you get 2t. Differentiate 6t, you get 6. Differentiate 7, you get 0. So the derivative of that magnetic flux is 2t plus 6. Substitute the time 2. If you fix the time there, you get 2 times 2 plus 6, which will give you 10. Multiply that 10 by the number of turns there, which is 2,500. That will give you 25,000 volts. So the correct option is option A. This is from electromagnetic induction. All right, let us move on to question number 3. Get set. I hope you've written your question number. Let's see what we've got there. We are approaching the end of this challenge for June 2025, right? Make sure you stick around, stay tuned to GMAT 41, follow up with what I release, my updates regularly, all right? Like I said, at least twice in a month, I'll come live here and challenge you friends. Test your preparedness. Help you bolster the network of your brain as you look ahead to a forthcoming examination. And for other friends from other schools, all right, another part of the world, you also connect to this class, you learn from the stuff that we deal with on this channel. Most importantly, make sure that you take lectures on this channel. Make use of GMAT 41's playlist. You have video lessons there, different topics on your math, physics, and chemistry courses. All right. So make use of it. It's going to help you a lot. Let's look at question number 3. What do we have there? Here we go. The electrical potential at a point 5 meters from charge is 150 volts. The electric field created by the charge is, you have the options there, 750 Newton per coulomb. Option B, 750 volts per meter. Option C, 30 volts per meter. Option D, 30 Newton per meter. You have just 5 seconds to solve this question. Your time starts now. Time up. Let's see our first correct entry. Question number 3 of your Physics 102. Remember, we have just 2 questions left, question 2 and question 1. Your entry, first entry is here. The time given is sufficient for this question for you to provide your answer. Of course, this problem is 1 plus 1. Yeah. All right. The first entry we have here by Ezeagu Emmanuel is option C. And that happens to be the correct answer. The next option by Erinze Umezilike, option B. Thank you for attempting. Drama moment, you went for option C. That is correct. However, the first correct entry is by Ezeagu Emmanuel. Let us move on to our next question, question number 2. We are approaching the end of this challenge. Who is going to be the winner? Question number 2. The magnetic equivalent of Gauss' law is? The magnetic equivalent of Gauss' law is A. Ampere-Circuital law, B. Biot-Savart law, C. Lenz's law, D. Faraday's law. You have just 5 seconds to provide your answer to this question. Your time starts now. Time up. So can we have your entries? Ezeagu Emmanuel, you've provided your entry. Do you have any further entry? The time given is sufficient. This is such a question that once you don't know it, you don't know it. Any other thing you might try to do, only you know the source you are consulting. And time is up for this question. The correct answer is, anyway, Ezeagu Emmanuel, you provided option C, that is Lenz's law. Thank you for attempting. However, the correct answer to this question is option A, Ampere-Circuital law. Ampere-Circuital law is the magnetic equivalent of Gauss' law. Gauss' law is a law you encounter under electric field. The equivalent of it in magnetic field is Ampere-Circuital law. So the correct answer is option A. Drama moment, your option came after I had provided the answer. Okay? So the correct answer here is option A. There is no contender for this. No contender. Now, I have Biot-Savart law here. I would like to have you know that Biot-Savart law is the magnetic equivalent of Coulomb's law of electrostatics. Coulomb's law, you meet it in electric field. In magnetic field, we have Biot-Savart law. So that Biot-Savart law is the equivalent of Coulomb's law, but in magnetic field. Drama moment, you said you answered it already before, but I said the answer before your option came up. And meanwhile, the time I gave is more than sufficient. So I don't know why I didn't see your answer at the time. Okay? So you have to bear with me. Oh, network. All right, I understand. I understand, okay? I understand. But I wouldn't give you this. I won't give it to you. However, your answer is correct, okay? Your answer is correct. Like I said, please, I am open to hear from you, friends. Suggestions. What you think we can do in order to, improve the quality of this academic challenge. And I'm looking forward to the time when I'll be bringing you people live, like you'll be live with me, and I will quiz you, I will challenge you, right? Let's see, so that at least maybe we might have a time frame within which you are answering the question. I will ask you, you'll be live, everybody will be seeing you with me as I ask you the question. You work in it, you're solving it, and if network, obstructs you, everyone will be aware that network actually interrupted. Okay, so let's see. You can suggest. You can send me a message directly. You can make use of GMAETS 41's community on this channel. Like I said, if you go to the homepage, you will see View Community. Tap on that View Community. All right. A page will open where you can send message directly to GMAETS 41 on this channel. I will see it. I'll receive a notification on such message. And like I said, you can even upload a written something, maybe on paper. You can upload something directly. Assuming you solve something, you can snap and then upload it. I will still see it. Just similar to how WhatsApp operates. Okay? Because the truth is, I must be honest to you guys. Like I've always said, GMAETS 41 is a full-blown online school. And I want you guys to know about that. So this channel would have to be active, full-time. Make use of the community of this channel. Let us go to our last question. So thank you, Drama Moment. All right. At least you provided the option, but I'm not giving you that. Okay. Bear with me. Here we now move on to the last question of the GMAETS 41's fastest finger academic challenge for the month of June 2025, as we announce the winner. Are we ready for our last question on Physics 102? So here we go. So far, we have covered this question on Math 102 for those that couldn't connect at the time we are dealing with that. Remember, like I said, the aim, the purpose of this challenge is not just all about the prize attached. This is the end of Math 102, and then we moved on to Physics 102. The aim should be to prepare you to improve the network of your brain, test your speed alongside with accuracy. And while you are doing this, you yourself, you'll be proud of yourself. You know you're preparing. But make sure that you continue to study. Study your lecture works, from school. Follow up with GMAETS 41's updates. Take lectures also on this channel so that, of course, once we have this challenge like this, you can follow through. So our last question for June 2025, GMAETS 41's fastest finger academic challenge. Here we go with this question, and I'm going to count for you. Once your answer does not come at the end of my counting, then that question goes off. Here we go. Two resistors, 2 ohms each, are connected in parallel. The combination is then connected in series with a 1 ohm resistor. The equivalent resistance is option A, 3 ohm. Option B, 5 ohm. Option C, 2 ohm. Option D, 1 ohm. Two resistors, 2 ohm each, are connected in parallel. The combination is then connected in series with a 1 ohm resistor. The equivalent resistance is, if you've been following GMAT 41's classes here on this channel, or if you are a Z-Kite, a Unizik student per se, and you are in the GMAT 41's tutorials, you would remember that we dealt with stuff like this. Even today, when I released a live video lesson, right, on a particular practical work, I made analysis on this, how fast you can solve questions on this. Experiment E6. It's available on this channel already. So help GMAT 41, share the links to your friends, to your departmental WhatsApp group, so that those that are yet to do the experiment, to carry out the experiment on Physics 108 for this week, can have access to it. Then the calculation work, the follow-up calculation question, question number 3 and question number 4. Part 2 of the live section today, this morning, I released, solutions on that, and I explained how fast you can solve questions like this. All right, so this is the end of the challenge. Thank you all for connecting to this academic challenge, and I hope you have learned something good. The correct answer to this question is option C. And from the entry here, drama moment, your entry is the first correct answer. Is that with Emmanuel? Thank you for attempting. You went for option A, but the correct answer is option C, 2 ohm. The two resistors are 2 ohms each, and we are told that they are connected in parallel. When you have two resistors and their resistance value is the same, what you just have to do is pick one of the resistance value and divide it by 2. So in this case, where we have two resistors, each of 2 ohms, they have the same value of resistance, 2 ohms. Since there are just 2 of them, to get the total or combined resistance for the 2 resistors that are connected in parallel, just pick one of the 2 ohms and divide it by 2. Simply half of one of them. 2 divided by 2 will give you 1 ohm. Now, the equivalent of these 2 resistors that are connected in parallel, which is 1 ohm, is now connected in series with a 1 ohm resistor. So you now have 1 plus 1, which will give you 2 ohms. And that's the answer. Straightforward as that. Once again, what will you do to this question? The 2 resistors connected in parallel, since they are equal, pick one of the resistance value and divide it by 2. Here, the resistance value given is 2 ohms each. So pick one of the 2 ohms, divide it by 2, find a half, which will give you 1 ohms. Now, that parallel connection that gave us 1 ohm is connected in series with a 1 ohms resistance. So it's now going to be 1 plus 1, giving you 2 ohms. And this is how we have come to the end of this academic challenge. And I hope you appreciate what you have learned so far. Eziagu Emmanuel, I was rushing. I am glad to know that, okay, it was just that you rushed that caused that. Yeah, so you now have to say that you need to also continue to work on your speed plus accuracy. Very important. It's a gradual process, okay? Thank you for solving it and dropping the answer, and that's correct. You got it, okay? You got it. However, we had a first correct entry. Okay, so thank you all. It is now time for us to declare the winner of GMAT 41's Fastest Finger Academic Challenge, June 2025. We had what I would call 3 sections. We had what I would call 3 sessions. In the Chem 102 session, which is the first session yesterday, we had a tie. We had a tie. 2 persons appeared as the fastest finger 3 times. And these persons are Ehi Zibwe, right? And Ehi Zibwe, and then drama moment. Then in the stage 2, format 102, drama moments took the day. In stage 3, drama moment also won it, appearing as the most fastest finger with accuracy. Following this analysis, I am pleased to announce to you the winner of GMAT 41's Fastest Finger Academic Challenge, June 2025, the person of Drama Moment. That's a wonderful one from you. You will have to satisfy certain conditions to receive your gift of $3, which goes $1 to 1,000 naira, Nigerian currency. What are the conditions to be satisfied? Tomorrow you are going to be brought up live. We'll come on live here because you're going to receive the gift live, all right? Now you have to provide your name, your full name, very important, right? And then you would have to indicate if you're a subscriber, because you have to be a subscriber on this channel to participate on this challenge. So if you have not subscribed yet, you have to subscribe. Subscription is free of charge. There are no two ways about it. All right? So if you have not subscribed, you have to subscribe. Take notes, drama moments. So your name, you subscribe. You could tell us your school. Tell us your school. It's important. You can never tell. GMAT 41 is hosting things, launching things to help motivate students. Who knows? One day you could get a surprise package. Yeah, anybody can get a huge surprise package from GMAT 41. So drama moments, these are the things you have to provide. Your name, then you indicate whether you are subscribed or not. You have to provide a screenshot to show that you are subscribed. Your school. You have to send it to GMAT 41. The GMAT 41's contact is already available on this channel. I think every one of you should have it already. The contact is always on the screen, on the board of the GMAT 41. So send these details, please. Your name, indicate whether you've subscribed to this channel, and your school. Then tomorrow, we are going to come on live. Tomorrow is Tuesday. Just within 5 minutes or less, 5 minutes or less, we are done with the live session. I will bring you up live to the channel. Yes. Okay. That's what is going to happen. I am from Unizik. All right. That's good. That's good. Okay. If you're a subscriber, provide me with the evidence. Just send me this on WhatsApp. Send me these details. Your name, subscription evidence, and then school. Like I said, normal subscription is free of charge, so don't be scared about it, okay? You're not paying a dime to subscribe. Okay, so send me the 3 details. Then tomorrow, just 5 minutes or less, I'm going to give you the time now. Take note. It's going to be 9 o'clock, exactly 9 o'clock p.m. You'll be brought up live. I will send you the link that you will click in order to appear live. And then you will receive your gift, your package, your prize for being the fastest finger with accuracy. The GMAT 41's Fastest Finger Academic Challenge, June 2025. Thank you very much, and I hope to see you friends tomorrow, okay? So drama moment, I'll be waiting to receive these details from you, the 3 of them. Remember, your full name, evidence of subscription, your school. You have already said it is Unizik, but you can still, okay, for formality, as a protocol, send those details to me on WhatsApp. Do have a wonderful night rest. I'll be seeing you tomorrow. Bye-bye.